Okay, in the last video we reached to this point. We calculate the path difference delta L, which is equal to d sine theta. Now if theta is very small, if theta is very small, then we can say that sine theta is equal to tan theta. Like sine theta is equal to tan theta for theta is much smaller. Now for small theta, we have this path difference delta L will be equal to d into tan theta. Now if we look at this figure, here we have, I consider this triangle, this and this, like the triangle, this and this. This is D. I call this is this distance from here to this point P, I call it Y. So this is Y. This is angle 90, this one, and this is the angle theta. This is angle theta. So from this triangle I can say that tan theta is equal to perpendicular over base D. So if I put this value here, then delta L will be D. This is capital, not small d, it's capital D. So it's capital D. D Y over D. So this is the path difference. So our final expression for the path difference is delta L, which is equal to dy over d. What is d? It's the separation between the slit, this one. What is this capital D? It's the separation between slit and the screen. And what is y? Y is the distance of minima or maxima from this central point. Now we already calculate the path difference, so I will use my same figure again, but here I just write my path difference, which is delta L, which we have already calculate dy over d. Now we already discussed before that if path difference delta L is 0 or integral multiple of wavelength. The wave arrive point P will interfere constructively. And we have a bright spot, bright fringe or spot. What it means, we already discussed before in the case of interference of wave, mechanical wave, that when this path difference if this path difference is an integral multiple of wavelength, like path difference is equal to m lambda, integral multiple of wavelength. where m is 0, 1, 2 and so on. Then the interference will be constructive, like the wave arrived at point P. The two waves arrived at point P, like R1 and R2. They arrived at point P such that their path difference is this one. Then there will be a constructive interference, like there will be a bright spot. So for constructive interference, the path difference is its value is already dy over d. dy over d will be m lambda. Y is equal to, from this I can calculate the y value of y, which is d m d lambda over d. This is the distance of bright fringes, a bright fringe. The bright fringe occur when we have this value, like the position of first bright fringe. First bright fringe, a maximum, occur when m is equal to 0. If I put m is equal to 0, then the bright future position will be 0. So it means that if this is my screen, the first maxima occur here at the center, at this point. Now the second maxima for second bright fringe, a maximum, m value should be 1. So the second bright future fringe, a maxima occur at 2d lambda over d. This is the position of second, so I will put here first, this is second. This B stands for bright fringe, a maximum. And similarly for third, bright fringe, a maximum, m value will be 2. So the position of third bright fringe will be 3d lambda over d, and so on. Next we will calculate the position of first minima. Now we already discussed before, like in our previous video, that if the path difference is an odd multiple of wavelength, then the wave arrive at point P will interfere destructively. Why they interfere destructively? Because if the path difference is odd multiple of wavelength, then the two waves or the two rays are exactly out of phase. Like by out of phase means the crest of one wave fall on the trough of another wave. So the resultant wave will be a zero wave. So it means that the two waves, they interfere destructively. So there will be a dark spot at point P. we can say that for destructive interference, the path difference should be m plus 1 over 2 lambda. The path difference should be m plus 1 over 2 or 2m plus 1 lambda by 2. It's the same because these two results are equal. So for constructive interference, the path difference, which is path difference, we already calculated the relation. The path difference is dy over d. dy over d will be equal to 2m plus 1 dy over d will be equal to 2m plus 1 lambda divided by 2. From this we can calculate the value of y, which is 2m plus 1 lambda divided by 2, and we have this d goes to this point and this d comes to this point, where m is 0, 1, 2 and so on. So it means that if the path difference between these two rays, like the ray R1 coming from slit S1 and the ray R2 coming from a slit S2, in such a way that this path difference is odd multiple of wavelength, like this path difference is odd multiple of wavelength, then the ray interfere destructively. Once they interfere destructively, then there is a dark spot, a minima. So for the position of minima is given by this one. Now first minima, for first minima, m value should be 0 because first is this one, second is this one, third is this one. So if I put m is equal to 0, then y, this is the dark position of dark spot or dark fringes. So y d1, the first dark spot will be at lambda d divided by 2d. The second dark, for the second minima for the second dark fringes, m should be 1. So the position of second dark fringe or second minima will be, if I put 1 here, 2 ones are 2 plus 1, 3. So it's equal to 3 lambda d divided by 2d. And for third dark fringe or third minima, m value should be 2. If I put 2 here, 2 2s are 4 plus 1, 5. So yd3, the position of third dark fringe is 5 lambda d divided by 2d, and so on. So by this way we can calculate the position of first, second and third dark fringes, of the position of first, second, third and so on, minimum. Now next we will calculate the width of minimas, the width of fringes, which I will do in the next video. Thank you.